It was good. Acids and bases now. What is Arrhenius definition? Bonsall-Lowry Lewis definition. What needs? Okay, so aqueous conditions is required by Arrhenius definition. So Arrhenius definition is just when an acid or base associates, it's going to give H plus, which will result in H3O, or it'll bring OH minus. So Bonsall-Lowry, that's like, so an acid will donate a proton, so an H plus, and then the base will accept the H plus. So now Lewis acids will accept electron, like a lone pair. Bases will give the lone pair. Now, Arrhenius definition is, well, actually, I don't remember which was the most broad, but I feel like Lewis acid is the most broad. Then Bonsall-Lowry will be second broad, and then Arrhenius will be like Lewis acid will be most broad. Then Bonsall-Lowry will be within Lewis acid, and then Arrhenius will be within that. That's a good question I want to answer, actually. Are all Arrhenius Bronsted and then all are Lewis? Or is it other way? Yeah, so all Arrhenius acids and bases are also Bronsted-Lowry. However, not all Bronsted-Lowry are Arrhenius. So it only goes one way. So all Bronsted-Lowry are also Lewis. So that means if all Arrhenius are Bronsted, that means all Arrhenius are also all Lewis, right? So yeah, okay. So yeah. Bro, why is this AI so glitchy today, bro? Actually, I caught like a million types of them. Just close. Command Q. Close that. Okay. Damn. Okay, where was I now? Okay, so. Oh, we're still on the first question, bro. Okay. What is the relationship and strength of acid and base conjugate pairs? So, strong acids will have weaker base conjugates. Weak acids will have stronger base conjugates. It's opposite. And the same thing, weak bases will have stronger conjugate acids, and strong bases will have weaker strong bases will have weaker acid conjugates. So what is pH and pOH? So they'll follow it at room temperature. So pH, like it's just the power of hydrogen, pOH power of hydroxide. Pretty simple stuff. So 25 degrees. So I want to ask, what happens if it's not at 25 degrees? That's something I'm going to ask later. Well, I'll ask it in the end. So what is dissociation constant? So dissociation constant is just the ability for it to dissociate into two, just how fast it's able to do it. The formula, it's right here, is products of reactants. We don't include water, so the reaction would be HA plus water results in H3O and then A minus, the conjugate base. And then you're going to have Kb, which is going to produce HB plus and OH minus, so that's going to be your products. And then you're going to have B as your reactant, like the base, plus H2O, but H2O is liquid. So high Ka or high Ka or Kb, that results in high dissociation constant, which means that it's strong. That means it wants to dissociate. That means it's wanting to do its reaction, so that means it's strong, right? Yeah. So then pKa or pKb less than 0 means that it's going to be strong, because pK is the negative log of Ka, or is the log of Ka. I think it's the negative log of Ka, so that means if you have a high Ka, then you're going to have a small pK. Ka greater than 1, strong. Binary acids, where are they? So binary acids are the halogen groups. So, the halogen groups, we got F, Cl, Br, I, those ones. So, it's like HF, HCl, HBr, HI. So what does the size mean for strength of acids? So as you get bigger, so like iodine, that's a stronger, HI is stronger than HBr. Why? Even though, so HI is stronger than HBr. Why? I minus is bigger. It has more layers of electrons. So when H loses that hydrogen, it's going to have a negative charge. That negative charge can be distributed along the larger molecule, which makes it more stable. The strength of an acid depends on the stability of the anion. So I minus is more stable than Br minus because I minus is bigger. So now you might be asking, well, I was asking, why is F minus not more stable than the other ones because the most electronegative? Well, it also comes into atomic radii, like what I was saying. I minus has a long bond length with the H, so the H is more ready to leave. So that weaker bond makes it stronger acid, while F minus is strong. Like F is small, fluorine is small, so that HF bond length will be pretty short, and it'll be super attached to that hydrogen, so it'll be hard to leave that. Make the hydrogen leave, so it's going to be a weaker acid compared to the others. And this is true, like, so I brought no clean socks, so it's like HI, HBr, and HCl are all strong acids, while HF is not included in that list. So yeah, so oxide acids are literally just putting in oxygen with those binary acids. So what are they? Yeah, like I said, they have oxygen. So what determines the strength? What determines the strength? So if you have more oxygens, that means you're more strong. Then there's another thing. So if you have more oxygens, you're more strong. Why are you more strong? Because when you lose the hydrogen, you're going to have more electronegative oxygens to stabilize that negative charge. And if you're more stable, then you're more strong. Second reason, I'm not too sure actually. It's the electronegativity of the central atom. So if you have higher electronegativity, then you're going to be stronger. So it's kind of opposing the binary acids, but I think the oxygen thing is more important. So what are neutralization reactions? That's when a strong acid, strong base react. Maybe not, don't have to be strong, just when acids and bases react and you form a salt. So I made this mistake multiple times during the practice questions. You have to balance the mole, like the normality, like the moles of H plus and OH, because one H plus will go to one OH minus, and that's how it works. So if you happen to balance it and you have two H plus, like H2 SO4, then you're going to have two hydrogens, and then you got to multiply the OH moles by 2 in order for everything to work out. What are salts a product of? They're a product of neutralization reactions. Like another product of them is water. Like it's just like reactions, bro. So how do you determine if a salt is acidic or basic? So so you have like different conditions, right? So if you have a strong acid and a strong base, you're going to end up with a neutral salt because the strong acid will create a conjugate that is neutral. The strong base will create a conjugate that is neutral as well. Neutral plus neutral equals neutral, so neutral salt. If you have a strong acid and a weak base, that strong acid will become neutral. That weak base will become slightly acidic, so you're going to have acidic salt. If you have a weak base and you have if you have a weak base and a strong acid, then that weak base will become conjugate acid, so you're going to have slightly acidic salt with the basic being neutral. So weak acid and weak base, it depends on if it will make a salt, but in the video I talked about, it does not make a salt. You're not able to make salts from weak acid and weak base, apparently. What is a buffer? A buffer is a solution that resists a change in pH. It's composed of an acid and a conjugate base. So the acid part will react with the buffer with the base that's put in, or the acid portion will react with the base that's put in. Wait, I said twice. The base will react with the acid put in, then the other way around. The Hasselbalch equation, that is pH is equal to pKa plus log base over acid concentration, or moles, doesn't really matter because if it's the same concentration then it's chill. I'm not saying anything. Solution that resists pH change containing weak acid and base and its conjugate. pH is equal to pKa plus log A minus, so that's going to be the base because it's going to accept the proton, right? Yeah, I think so. Okay, so how will a strong acid base react to a weak? So it says that it'll dominate overwhelming buffer capacity, But I think what I'm trying to get at is that if you have a buffer and you put a strong acid in, then you're going to increase the acid concentration and you're going to lower the base concentration, and therefore your pH will become lower. That's kind of what I'm trying to say here. What are titrations used for? They're just used for finding out the unknown concentration, unknown moles of acid or base. You got the titrant and the anhydride. Wait, not anhydride. I don't really remember. What titrant and what? Something else. But yeah, okay. And then equivalent point of a strong acid and weak base. Strong acid and weak base. So you're gonna start with like a strong acid, right? If you start with a strong acid, like that's your like anhydride or whatever, the eluent, no, not eluent. Bro, that's organic chem, bro. I don't know, but you're gonna start with a low pH. Wait, EQ point of okay, a strong acid will have an EQ point near 7. Weak acid will have it a bit. I want to say a bit higher than equivalence 0.7. But anyways, if you add a weak acid to a strong base, okay, I feel like what I'm trying to say in the first question is strong acid and weak base, but I just wrote it twice. So if you start with a strong acid, that's your thing in the thing, and then you titrate it with weak base. You're going to start with a very low pH initially, and then you're going to go up, and then you're going to have a pH of just below 7. The equivalence point will be just below 7. It will not be exactly 7 because you have a strong acid, not a strong base. Then if you add a weak acid to a weak base, I think you get the gist, but it's like, if you start with a strong base, you're going to start at a very high pH, and then you're going to go down, have an equivalence point just above 7, and then you're going to go down. So yeah. So my question is now, how does pH and pOH affect based on temperature then? But yeah, that's pretty much all. So, bro, why is this so glitchy, bro? Okay, at 25 degrees Celsius, kW equals 10 to the negative 14. So pH plus pOH equals 14. As temperature increases, oh, one of my friends told me about this. kW will increase more H, so pH plus pOH will be less than 14. That means the neutral pH will decrease below 7. Conversely, lower temperature causes kW to decrease pH. So how would each individual inshallah, okay, as temperature rises, kW increases. H plus and OH minus, so pH decreases, pOH decreases. Okay.